Claude Code is one of the most popular AI tools in the world, yet most people have no idea how it actually works. So in this video, I'm going to break it down for you. You'll learn what an LLM is actually doing underneath the hood, how tool calling really works, what goes into the context window, and how guardrails fit into this. Then I'll show you a fully functioning minimal version that I built in Python so you can see exactly how an agent harness comes together. And just a quick thank you to HubSpot for sponsoring today's video, but more on that later. So I have two main goals for this video. The first is to understand every moving piece inside of Claude Code. So tools, memory, context, guardrails, whatever, I want you to understand all of them and how they work together. The next is to show you how to build your own. So I've already built one, and at the end of this video, I'm going to walk through all of the code and you're going to see in practice what an agent harness actually looks like. So let's start by defining what Claude Code is. Now, Claude Code is effectively an agent. This is some LLM that can run in a loop, call tools, and interact with the world, and then an agentic harness. Now, this is the software that's wrapped around the model, so it handles the loop, the tool implementations, the permission system, and effectively the model predicts what it should do next. The harness really takes over and takes control. So you can have a quick look at this diagram here. In the center, we have the LLM. This is kind of like the brain. It's really powering everything. We have the loop. The loop is things like tools, memory, context, assembly. And then we have the harness, which really controls the loop and allows the LLM to take various actions. You'll see what I mean in a second as we go deeper into the explanations. Now, in this agentic harness and inside of Claude Code, there's 5 main building blocks. The first, the model, we already talked about that. The tools, these are things like reading a file or searching the web or deleting something or looking through your file system, right? Next, we have memory. This is persistent information that the agent can remember. We then have context. This is what's actually fed to the model so it can understand its surroundings, see what's around it, know what the result of a tool call was. And then we have guardrails, and these are the things that are built in to prevent the model from doing something that it shouldn't. Now, I'm going to go through each block one by one. Let's start with the model. Now, when I say model, I'm talking about a large language model. This is effectively a giant text predictor. All it does is predict the next token in a sequence. So if you tell the model, hey, what's my name? Its response is going to be, my name is X, or I don't have a name. It's predicting what the response should be based on what you tell it, and that's really its entire job. Now, important things to understand is that the model doesn't remember anything. If you chat with the model one turn and then you chat with it the next time, it doesn't remember what you said. In order for it to remember that, we have to pass what was said previously into its context window. You'll see what I mean in a second, but by default, the model is stateless. Next, it only sees the context window, okay? So if something isn't inside of the prompt, it's not passed into the model, it doesn't know that it exists. And you can see a quick diagram here, right? We put some text in, what files are in the project, model predicts the most likely next token, and then it gives you the response, okay? And sometimes these tokens can actually be tool calls, so they can be something that's not text that the user is going to see, but something that triggers a certain action to run inside of the agentic harness. You'll see what I mean in a second. I don't want to confuse you for right now. Next, tools, probably the most important part when it comes to building an agent that's actually useful. So we have a few different types of tools here. Now, in something like Claude Code and most of the AI agents that you use, they come with some built-in tools. Now, these are I/O tools or input-output tools, and these are basic ones that allow the model to read, write, edit, run a bash command, search for something, etc. So when the model's writing a file, it's not really writing a file. What it's actually doing is calling a tool that allows it to write a file. So it's calling the read tool to actually read the contents of the file. It's calling the write tool to change something in the file. It's calling bash to run a shell command. You get the idea. Now, additional tools are things like MCP servers and plugins. So you can add multiple other tools inside of an agent like Claude Code, and all you're doing is just telling the agent, hey, there's these other tools you can call. This is the name of it. This is what they look like. And if you want to call it, just tell me, and then I'll call it and give you the response. You'll see what I mean in a second when we get into the harness, but basically we have MCP servers. These are kind of external tools, and then plugins, typically they can bundle multiple tools together, so maybe multiple MCP servers, commands, skills, all of that kind of stuff, but you can install these and integrate them inside of the agent. Now, the key idea here is that the model doesn't run these tools. The model asks for the tool or requests to call a tool, and then the software runs the tool itself. If a model wants to make an API request, for example, it can't actually make the API request because remember, all the model's doing is just predicting text. What it does is it writes some text that says, hey, I want to call this tool, and then the software that's viewing what the model is outputting goes, oh, the model said I want to run a tool. Okay, let me run the tool, let me get the response and give it back to the model. And this is that key loop to understand. Next, we move on to memory. So I'm just going to pull a few examples here so you can see what it looks like. Now, memory is effectively just files, okay? When we say that the agent doesn't have any memory, that's true. It doesn't have any memory. It doesn't by default remember something. The way that it would remember persistent information is by writing that content into a file and then reading that file or having the contents of that file in its context window or its prompt. So you'll see inside of tools like Claude Code that you'll have a structure that looks something like this. You'll have a claude.md file. This is a memory file that's always loaded, which means it's always put into the prompt. So it's always going to remember what's inside of here or know what's inside of here because it's injected in the prompt. Then there might be a memory folder. Inside of the memory folder, there may be different files, and these files can be loaded when they're needed. And then you might have things like skills, and skills are just markdown files that can be loaded to perform some type of task. So the idea here is that the model may not load all of this information at once, but it may request a memory artifact or say, hey, I want to go to my memory, see if there's information here, read the contents of that, and then it will be able to perform some task or maybe update the memory or whatever. So on the right-hand side of the screen, you can see two very simple terminal commands, cat, which is just reading a file effectively, of user preferences.md. So we may ask the model something like, hey, what are my user preferences? If it doesn't know what the user preferences are, it might go, okay, let me search through the different memory files that I have. That's a tool call. Okay, I see that I have this memory file. Let me look at that memory file. Again, another tool call. Oh, this is what's in the memory file. Okay, here are your user preferences. So I want you to understand that the model doesn't save anything by default. In order for it to remember, that information needs to be in its context. It needs to be passed in the prompt. And typically the way that it's injected in that prompt is by the model requesting a certain tool call. The tool call results in some information, and that information goes back to the model, like you can see here with these memory files. Next, let's talk about the context window, where this is all going to start to make a little bit more sense. So when we say context window, this just refers to the information that the model is currently seeing. This is pretty much the same thing as a prompt. It's just one super long prompt. So what you say to the model is you prompting it, right? But that information that you say is being combined with a ton of other text, and that other text includes a lot of the information that we just talked about. So here's an example of a context one. I'm going to go through a few kind of points here. So first, we have a system prompt. Now, system prompt is general information that's always passed into the model so it understands what it should do or how it should perform. So it says, your Claude Code, an agent that helps with software, follow the instructions, whatever, right? Tool definitions. This is super important. So what we do is we define, hey, you have access to all of these different tools. If you want to call one of these tools, just let me know, and then I'll trigger it for you. This is what we're telling the model. Next, skill definitions. So things like markdown files or information that it can read. Memory, right? That claude.md, maybe other files that we're bringing in here. And conversation history. This is everything that's occurred so far in the current session. So when I say the model doesn't remember anything, well, it doesn't. The reason it knows what we said previously is because we're taking that information and we're stuffing it into the model, so it's forced to see all of that. And then tool calls and results. So the model maybe wants to read a file. Okay, we're going to read the file. Well, we got to give that information to the model so it knows what's actually in the file, so we stuff it in the context. And then lastly, it doesn't show in here, but we would have our prompt. So whatever we're actually asking the agent to do, that would go at the end typically, and then the model would predict from there. So effectively, we just have a ton of text, right? This text goes into the model, and then that describes the tools, the system prompt, the skills, what we actually want to do. And by having all of that information, it seems like the model's super smart and remembers things, but really all it's doing is just looking at a huge wall of text and then predicting more text that we can interpret and do something with. And then lastly, let's look at guardrails. Pretty straightforward, but you'll see sometimes when you ask a model, hey, read this file, hey, delete this, hey, do something, right? And it pops up like a little box that says, are you sure you want to do this thing? Well, that's a guardrail, and effectively this is enforced by the software, not by the model. There's guardrails like human in the loop, which is what I just talked about. Also limits, you can't do things too fast, for example. And the way that this works is that you can have a tool call that's limited by maybe human in the loop. So we're not going to call this tool unless the human presses a button. And the reason why we're able to do that and the model can't just override that is because this guardrail is written by the software, not by the model. And this is the key thing you're going to understand, is that the model is just predicting text, right? What happens after that is controlled by normal human written software, right? Or AI written software, whatever. And if we want to call a tool, for example, we can write something in the software that says, hey, in order to call this tool, you need to press this button, right? And then we press the button and it will call the tool. Hopefully that makes sense. And we're going to keep going after a quick word from today's video sponsor, HubSpot. So here's what's cool. Everything that I just showed you, the memory files, the skills, the tools, none of that is limited to just writing code. And that's the perfect segue to tell you about a great free resource. Now, HubSpot put together a free guide called Master Claude Code for Marketing, and it's basically everything from this video applied to marketing. It's 4 complete workflows and 12 copy-paste prompts that take you from an idea to a live deployed asset in just one Claude Code session. And I mean the real concepts. The guide has you set up Claude.md memory, turn your best workflows into reusable skills, exactly like the skills that we talked about earlier. And also it shows you how to plug in tools like Firecrawl and Perplexity to crawl competitors' sites and find positioning gaps in about 20 minutes instead of spending days doing this. Now, the workflows also build on top of each other. You have competitor research, then an interactive lead magnet, which is an actual tool, not just a PDF. Then you have a landing page and you deploy this straight from the terminal, then a 3 email welcome sequence. So you can run all 4 and you got a full go-to marketing system in just one session. So if you're a developer, this is honestly the playbook for marketing your own side projects, and it's completely free with the link in the description and also the pinned comment. Big thanks to HubSpot for sponsoring this video. Now let's get back into it. So now that we understand the key building blocks, I want to dive into more specifics, more details about how these things work together. So first, so important, it's really the root of this entire video, I want to discuss again what an LLM does. Now all it does is one thing. It literally just predicts text. Don't think of an AI agent, or not an AI agent, LLM, a model, right, as this super complicated magic black box. Literally all it is a text predictor. So for example, my favorite programming language is, and then it has a 71% chance that the next word should be Python. Okay, now after that, the next chance is because, then it's whatever, and you get the idea. Literally all that we're doing is we're just predicting tokens in a sequence, and those tokens can end up being really complex. They can be JSON, they can be a tool call, they can be, some really insightful response, whatever. But the idea is that the model isn't really doing anything. It's literally just spitting out text, and that text that it gives us is the thing that we interpret and then do something with, okay? So it has no memory, it has no state, it has no goals. It's literally just, hey, you get all this text. What do we think the response should be? Gives us the response and we go from there. That's it. Okay, that's what the model does. If you understand that, this stops seeming like magic. Okay, so how does a model call a tool then? Because this is the thing that allows it to do something. Well, it writes text, okay? So you can see it literally just gives us something that looks like this. If it wants to call a tool, it gives us something like JSON, this format, and this is the text that it gives us. It says, hey, my type is tool call, the name of the tool is read file, and the arguments I want to pass to the tool are src main. That's it. It just gives us that. And then what happens is the model outputs the structured text, and the harness, so the software that's running this model, right, that's allowing you to type something in, then takes this tool and calls it. So it parses the response, right, calls the tool, it gets the response from the tool, and then it gives it back to the model. It says, hey, you wanted to call this tool? Here's the response from that tool. And that goes back into the context. It goes, okay, this tool call resulted in this. Okay, now I want to call this tool. Now I want to do this. Now I want to do this. And it's like, it's just instructing a piece of software what to do. That's it. That's basically the idea, okay? So the whole system runs like a loop, right? Effectively, we build the context, so we assemble the full prompt. So this is all the tool definitions, all the things the model could possibly do. The model predicts what it should do next, so it can call tool, it can output text, whatever. We check with a guardrail, okay, should we be able to do this? Should we call the tool? If we can, we execute the tool, and we pass the tool result back into the context. That's it. That's this loop, right, where the model's just giving us the text. So if you look at the right-hand side, we say, hey, we get a reply from the LLM. If the reply calls for a tool call, okay, we're going to run the tool, we're going to add it to the context, and we're going to continue. That's literally how all of these agents run. So with that in mind, how does it know what tools actually exist? Well, you might remember previously that in the context window, we typically provide what I'll refer to kind of as a menu that describes what tools are available. So we have the tool's name, their description, their parameter schema, and we put that in the context window and kind of list that out. So the prompt goes something like, hey, you are Claude Code, you can call a bunch of tools. Here are the different tools that you have available to you. Feel free to call them, right? And then we have a read file tool, a bash tool, a search tool, whatever. So the model knows, okay, I can use these different things. Then what actually happens is the model says, hey, I want to call this tool, right? It writes its text. It says, hey, here's the JSON schema. Here's how I want to call the tool. And then the harness, so again, the piece of software, not the model, looks at the response, goes, okay, you want to call this tool. All right, I'm going to call this tool. So it then actually implements it by running the tool, right? So it looks at the schema. It says, okay, I need to call this function. Okay, I'm going to call this function. Okay, the function's going to do this thing. I'm going to get the response, and I'm going to bring it back to the model. That's it. So we literally just put a menu of tools, and that's why you may hear sometimes that it's not great to have so many tools available to these AI agents, because if you do, then sometimes they can be a little bit confused, they can pick the wrong tool, and if they're looking at thousands of different tools, it's more likely they're going to pick one that's inaccurate than if you just gave them 5 or 6 really small targeted tools, right? Hopefully you get the idea. Okay, so the model reads a menu and then the harness effectively cooks, right? It's like someone sitting at the back of the kitchen saying, hey, I want this thing. And then we actually go into the kitchen and they start cooking it up and they give it back to us, right? I'm a customer. Hey, I want a pizza. Okay, I don't actually make the pizza. It goes to the kitchen makes the pizza, gives it back to me. I consume it and then I can order the next thing. I think that's a pretty good analogy to understand how the LLM works and what these AI agents are really doing. Okay, so now let's talk a little bit about the guardrails, right? Pretty straightforward, but the basic idea is that the model can only output text, right? So maybe it wants to run a command, so it outputs a tool call that looks something like this. RM is like deleting, right? So we bring this to the harness. The harness says, hey, okay, I'm going to check this command. If this is a command that's something that's destructive, it's not in our allow list, it's something that maybe could have some harm, we're going to ask the user for permission. So just going to go to the user and say, hey, do you want to allow this command to run? And then if I press allow, it says, okay, we're going to run it. It runs the command, and then it gives us the output here back to the model. That's it. That's all the human in the loop guardrail is, and you can build this in super easily. So understand that's how they work inside of these pieces of software. So really, guardrail is just an if statement that says, hey, if this thing is whatever, ask the user. If the user approves it, run the command. If they don't approve it, don't run the command. So continuing, let's have a quick look at what the model actually receives in the context window. I know we had a quick kind of sample before, but I just want you to see kind of the size and space that some of these things take up. So a context window is the size, right? Or how large, how much information we can pass to the model. Now, really smart models have big context windows, 1 million tokens, which you can think of that like 1 million words, for example. Maybe a smaller model has a smaller context size, like 200,000 tokens, right? And as this kind of context window fills up and has more information, typically the model actually performs worse, especially when it starts getting 80, 90, 100% context window, because it has too much information to process. But when you look at a context window, typically you're going to see a distribution that looks something like this, where you have a system prompt. Maybe this takes up, a very small percent, like 1, 2% of the context window. You have memory files. Depending on how much memory you have, again, can be a small amount of tokens. Tool definitions. This can be quite large because the tools are pretty complicated. There's a lot of characters. The schema can be long. Then you have things like the conversation history, kind of this gray bar here, right? That can be quite large as well because you can be going back and forth and have everything you've said, everything the assistant or the agent has said, and all of the tool call results, right? Then you have skill definitions. So things like different markdown files that it has accessible to it that it can read in full if it wants to execute a skill. And then tool calls and results. So it kind of goes in with the conversation history. All of the resulting information from the tool calls can take up a lot of space. So just understand that context engineering, right, is effectively engineering what pieces of information here are going into the context window to attempt to get the model to predict the best next token. Best next token meaning best next response. So when all these people come out and they say, hey, my model's the best at tool calling, it's the best at doing whatever, it's the best at writing code, that really just means that they've written a model that's really, really good at looking in the information in the context and then giving us an accurate response that does something meaningful like write a file or write a test or open a browser, whatever it's supposed to be doing by predicting the correct next token. Okay? So let's keep going and let's put it all together. So I'm just going to go here so we can see everything that we have. We have context, right? We assembled the prompt, we put all the information together, we feed that to the model. This prompt includes the memory, the tools, all the other definitions that we talked about. We then give that to the model. It predicts the next token. We run it through a guardrail if there's a tool call to see if we can actually execute this. We then execute the tool calls, right? And then dump that back into the context and keep looping. That's literally it. That's all we're doing. And it's just this long loop that's going through here. So skills, MCPs, approvals, whatever, they're all inside of this loop. So what we're going to do now, just have a quick look here, is we're going to build this in Python. Now, technically, you can build this in 15 lines of code, as you can see right here. I'm going to make this a bit more complex so we can actually go through and you can see the details and get a better sense from the engineering perspective what this looks like. But this is an example of a simple model, right, or a simple AI agent. We have messages, we have a loop, we trigger the LLM. If we're calling a tool, we check if it's approved. If it is, we run the tool, right? Then we take this, we put it back into the context, and we keep looping. And that literally covers everything that I went over in a super simple Python script that should be easy to digest. So now let's go into the code editor and let me show you a running agent. Okay, so I'm inside of my code editor here, and I've got kind of a mini version of Claude Code running. I want to show you how it works first of all, so you can kind of see the output, and then we're going to dive into the code. So this particular Claude Code that I've written has access to some different tools, and it can write files, it can read things, and it can generate code just like Claude. So maybe I want to say something, can you write me a simple tic-tac-toe game in Python, please? Okay, so I'm going to prompt it and then press enter. Currently, I'm using Opus 4.8, and you can see what's happening now is it's giving me the tokens in, the tokens out. It's calling a tool right now. The tool it's calling is list files. So it's now listing all the different files that we have in our directory. It's now writing a file. So you can see it's called write path. It's asking me with a guardrail, do you want to write this? Yes, I will allow this write. And then we're going to keep going. Now it's going to take a second here. It's not super fast, but it says it created tic-tac-toe. And then down here, you can see we have this tic-tac-toe file that it just made, right? And we could execute it and run it and change it as we want. So there we go. Like we literally just got a full output from Claude Code. If I want, I can clear. So if I clear, I'm going to clear the current history. So now if I ask it, what did you just do? It shouldn't remember because we cleared the history, so it shouldn't have any, I haven't done anything yet. You can see we're at the beginning of the conversation chain because I cleared it. I also can change the model, so maybe I want to change to Sonnet, so /model Sonnet, for example. Okay, we've now changed it. What model are you? I'm not sure if it's even going to know this, but let's see if it gives us the response. Okay, and you can see Claude Sonnet, I'm mini Claude Code. Okay, interesting. /help, and then we get the different commands, okay? And then I can quit out like that. So I just made, again, my own Claude Code. Like it can edit files, it can write files. I can do something much more complex. Of course, it's not going to rival the real Claude Code, but this is in about 300 lines of code, which I want to start diving into right now, starting with the model. So you can see I have different files up here. I've tried to keep them really separated so that you can understand how each part works. And even if you don't understand Python or you're not a developer, don't worry because you're going to be able to read this just like it's English and you'll kind of understand the different pieces and at least the sequence in what's going on here. Okay, so this model file is the only file that's related to actually using a large language model. Now I'm just using the Anthropic package here, a library. Of course, I could do raw HTTP requests if I want, but effectively all this file does is define here are the different models. Here's the default model we're going to use. It loads in my environment variable because, I'm not Anthropic, so I need to have my own environment variable in order to call the model. And then what I do is just create a client, and then I can just make a completion and send a request to the model. So you can see literally all this does, because this is the only piece of code that's actually interacting with an LLM, right, is it just asks for a completion using this model. This is the maximum tokens. This is the system message. These are the previous messages, and these are the tools. Now, these are just combined internally in this framework into one large system prompt. I could have combined it myself, but effectively all this is going to do is just look like exactly what you saw in the presentation, where we have, okay, here's the system prompt, okay, here are the previous messages, okay, here are all of the tools, and then it can give us a prediction. That's it, okay? That's literally all the model is doing. It's all defined in this, 52 lines of code, where really the only call is this line down here. Next, let's have a look at the context. Now, this is how we start assembling the context for this model. So you'll notice I have a base prompt. The base prompt defines what this agent is. So it says you're a mini Claude Code, CLI coding agent. Here are the rules. These are the things that I want you to do. Then we have this load memory function. We'll look at memory in a second. And all we do when we build the prompt that we're going to pass to this model is we take the system prompt, right? And then we just add all of our memory. So memory can be in something like this claude.md file where we can write any long-term memory we wanted to know. Okay, so we just take that, we combine it, and you can see when we combine it, we say, hey, here's the project memory, and we just inject that directly in the context. Next, we have the memory itself. Now, the memory just loads the memory file. So all it's doing, right, is it's looking on our computer, says, okay, is there a claude.md file? Yeah, there is a claude.md file. Okay, great. So I'm just going to take that, I'm going to load it, and then we're going to combine that with the system prompt, and now we've got that all combined together. Next, we go tools. Now, tools are a little bit more complex, but what I want you to understand here is that we have implementations of tools, and then we have tool definitions, okay? These are different things. It's super important. So let's start with the definitions, actually. The definitions is the only thing that the model sees, okay? It's not actually able to call the tools, right? It's just able to know what tools are available and then predict text that says it wants to call a tool. So you can see that we have all these tools. We have a name of a tool, list files. Here's the description of what the tool does. Here's what the schema looks like for calling it. Hey, we bring in an object. Object needs to have all of this. Okay, read file, same thing. You know, read a file. If you want to read a file, you got to call this tool. Here's the input schema. Here's a required property. Same thing, bash, whatever, you get the idea. This is all that the model sees, and when it wants to call a tool, it will call it in this type of format. Next, like I said, we have the implementation. Now, these are the actual tools themselves, the Python functions that need to run in order to execute the tool call. So we have a function that lists different files, one that reads a file, one that writes a file, and one that runs a bash command, okay? So we have these 4 different functions. Then we have these kind of function mappings. So we're saying, hey, if the model wants to use bash, well, this is actually the function we're going to run. If it wants to use the write file tool, this is the function we're going to use. And then we just have a description of tools that are read-only, so ones that will just let it do automatically. And then any other tool, there's going to have a guardrail that's implemented, which you'll see. And then to run a tool, we just take the name of a tool, we take the arguments for calling the tool, and then we just call that tool function, right, that's in the kitchen, the actual implementation, with those different Python arguments. Don't worry too much about this code if it looks confusing, but that's the idea. Next, we look at guardrails. Again, guardrails super straightforward. Hey, if the tool's in read-only tools, yeah, we're going to let you call it. If it's not in read-only tools, we're just going to ask you, hey, do you want to allow this to run? And if you type yes, we'll run it. If no, we won't. We're also going to cap how many times we can run. So we can only do 25 tool calls at once to make sure that we don't have this kind of infinite loop and the model goes crazy. Next, we move to the agent. So the agent imports some of this stuff. It imports the model, the tools, the guardrails, and the context. Remember those building blocks that we talked about. So inside of the agent, we define the model, we build the system prompt, and we start keeping track of the conversation history, so the messages that we're going to have. Now, when we want to run one turn, first thing we're going to do is we're going to take whatever the user wants to say, and we're going to add that to our conversation history, right? So we keep track of that. Then we're going to loop a maximum of the max tools calls per turn, right? And we're going to say, okay, let's send a request to the model. What we want to do is we want to use this model. This is the prompt we want to use. Here is the conversation history, and here are the tool definitions the model has access to. Okay, then we get a response from the model, so it's response.content. We're going to add that right back into the context so we remember it. And then what we're going to do is we're going to look in the content, and we're going to see if this has any text. Now, if it has any text, we're going to write it out because the text is something that the user will be able to read. Now, if it doesn't have text, it's going to have a tool call, which you'll see in a second, but this is the idea, okay? We then look at the usage as well, and we just print that out so we can see it. Next, we check if the model wants to stop. So this is the piece that probably you're not aware of. How do we know when to stop? Well, the model will actually tell us directly if it wants to stop. Usually, it will do that by just giving us a text output. So if it doesn't call any tool, it means it's not waiting on some response. So what we can do is we can just immediately terminate it, and we don't need to keep triggering it to run multiple times. Because what you're going to understand, right, is that what we need to do when we call this model is we have to call it multiple times, like get multiple predictions for one single prompt. So the user says, hey, build me a tic-tac-toe game. Okay, first I need to read the file. Well, to read the file, that's one model turn, right? It's like one trigger in that loop. So I'm going to read the file. Well, to read the file, I need to actually go to the harness. I need to get the content. Then I need to take the content and pass it back into the context and run the model again. So the model may run 20, 30, 40 times, whatever, before it actually gives us any human readable output. And that's why it's in this loop, and it can take a certain amount of time to run, right? So that's what this loop is doing right here, just going up to the maximum tools. Now, as soon as it doesn't need to do anything else and it has a response, we can just stop. But otherwise, we need to go through and we need to look at the tool use. So we're saying, hey, if there's not tool use, just continue. Otherwise, what we need to do is say, okay, well, it was tool use. So what are we going to do? Well, I'm going to check if I need to approve a guardrail for this particular input in this particular function, and then run the tool. Okay, and if you don't approve it, then I'm just going to say, hey, user denied the tool call, and then I'm going to append this as a tool result to our, conversation history, right? So we say, hey, this is the tool result. Then again, we add this back into the conversation history, and we keep going. This is how the agent loops. That's all that's going on. It's either calling a tool, not calling a tool, giving us text, and then adding that all back into the context and keep looping and looping and looping and looping until it's finished. Okay, and then the last file is just this main file here. This is just for handling the different commands and stuff. Don't worry too much about this, but effectively all this is doing is just saying, hey, we're going to let the user write whatever prompts they want. As long as they have a prompt, we're going to pass that over to the agent. The agent's going to process that in its agentic loop. It's then going to give us the response back. And that is literally Claude Code. Now, of course, Claude Code is, I think, 500,000 lines of code, so it's a little bit more complicated than what I have here, but this is really the architecture. This is the flow. This is how things operate, and this is genuinely what's going on behind the scenes on all of the major AI agents that you look at, with just a lot of other, different features added in, okay? So I hope that this video was clear. If you guys enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in the next one.